All right, now, for those of you who may be confused as to why they said multiply each side by 9, it's because they want to get rid of the fractions. They want to get rid of the denominators. So to do that, you have to remember what you did back in about the 3rd, 4th, or 5th grade when you learned how to add and subtract fractions. You ask yourself, I got a 3 and I got a 9. Also got, technically speaking, I got a 1 there also. But I got a 3 and a 9. And I ask myself, what number is it that 3 and 9 can both go into evenly? And that number is going to be 9. If I list my factors, I would get 3. 3 times 1 is 3. 3 times 2 is 6. And then 3 times 3 is 9. Okay, and then for 9, 9 times 1 is 9. So the number that both 3 and 9 can go into evenly would be 9. So therefore, we multiply this entire equation, every part in it, we multiply it by 9. So x squared gets multiplied by 9. 2/3 x gets multiplied by 9. I wrote it as 9 over 1, so it'll be easy for you to understand. And then 1 over 9 gets multiplied by 9. Now, 9 times 9x squared is going to give me 9x squared. 9 times 2/3 is going to give me 9 times 2, which is 18, over 1 times 3, which is 3, and then 18 divided by 3 is 6. And that's how they ended up with 6x. And here I have 9 over 1 times 1 over 9. Well, 9 times 9 is 9. 1 times 9 is 9. And 9 divided by 1 is 1. Excuse me, 9 divided by 9 is 9. All right, so you can see that. 9 over 1 times 1 over 9. 1 times 9 is 9. And 9 times 1 is 9. And 1 times 9 is 9. So 9 divided by 9 is equal to 1. All right, so we hope that helps you out. Okay, example 6. Solve a vertical motion problem. Falling object. A window washer drops a wet sponge from a height of 64 feet. After how many seconds does the sponge land on the ground? Solution. Use the vertical motion model to write an equation for the height, h, in feet, of the sponge as a function of time, t, in seconds, after it is dropped. The sponge was dropped, so it has no initial vertical velocity. Find the value of t for which the height is 0. So we use our vertical motion model. Everybody should know the equation by now. H is equal to a negative 16t squared plus vt plus s. Solution. Substitute 0 for h and 0 for velocity and 64 for s. So the height is 0, the velocity is 0, and the initial height was 64. So this is going to cancel out, and we're going to end up with a negative 16 times t squared minus 4. A negative 16 times t squared minus 4. All right, now let me explain to you what they did going from here to here. All right, now what they would end up doing, this would disappear, right? That's gone. So you would actually end up with a negative 16t squared plus 64. But what they're doing here, they're recognizing a little bit beforehand, only because they have prior experience, that they want the difference of two squares. So they factor out a negative 16. They factor out a negative 16. So when you write the negative 16 on the outside, you end up saying a negative 16 divided by a negative 16, that's going to be a positive 1. So all you're left with is t squared. Then you say 64 divided by a negative 16. That's going to end up being a negative 4. So now you have the difference of two perfect squares. Perfect, perfect, minus sign. And now you apply the same technique we've been doing this entire lesson. All right, so now we're back here, and we're going to end up with the square root of t squared is t. The square root of t squared is t. The square root of 4 is 2. I want a positive version and a negative version, or a negative version, positive version, same thing. So I end up with t minus 2 times t plus 2, and don't forget that negative 16. Now we're going to use the zero property, and we know that a negative 16 equal to 0 makes no sense, so that's gone. And so I'm left with t minus 2 is equal to 0, or t plus 2 is equal to 0. When I solve this, I end up with t is equal to 2, or I end up with t is equal to negative 2. Now we're going to disregard the negative solution of the equation. The sponge lands on the ground 2 seconds after it is dropped. Once again, time can't be negative, so we're going to disregard the negative solution of the equation, and the sponge lands on the ground 2 seconds after it was dropped.